Hello and welcome to Clear Water Quality. In this video I'm going to show the precipitation of silver chloride in a chloride solution, and we're going to calculate the solubility. First of all, I'm going to draw a schematic to show what this looks like. I'll start with a beaker of water, deionized water, and the only thing in it is some chloride, probably some sodium as well, sodium chloride, some positive ions. It doesn't really matter here, but we have 10 to the minus 3 moles per liter of chloride. And then after some time, in the same beaker, we're going to add some silver chloride, and we want to see how much of that is going to dissolve into the solution. And so a precipitant is going to form, and we have our silver and chloride. And the way we'll solve this is using the equilibrium equation, the mass action. And so we have the KSO is equal to the silver times the chloride. And in this case, the silver is equal to the chloride added, but it's not equal to the chloride in solution because we start with 10 to the minus 3. So the final chloride and the final silver will not be equal. So we'll put a, oops, let's see. Got to keep my colors straight here. We want to have a silver concentration here and a chloride concentration here. And so this will be 10 to the minus 3 plus whatever is added. Let's call that the silver. Yeah, call it the silver. And so in our final solution, what we're going to have is KSO is equal to silver times the quantity 10 to the minus 3 plus the silver. We can replace this with 10 to the minus 10, and then this is 10 to the minus 3 times silver plus silver squared. And so we can solve this as a quadratic equation. If you're handy with a solver on your calculator, you can solve it that way. Whatever is easiest. Be careful here though, because you do need to keep your digits because we're dealing with small numbers. And I get a solution for the silver of 10 to the minus 7 moles per liter. And this is the solubility limit for silver chloride when it's added to a chloride solution. So solubility limit when excess chloride present, and excess means 10 to the minus 3 molars. And so what we can see is that this is less soluble than in DI water. So the presence of the chloride excess caused the solubility to go down compared to what we calculated in DI water, which was 10 to the minus 5. So the result of adding that that chloride is that the solubility went down, and this is known as the common ion effect, which is that by causing or by adding the ion that reacts with the metal to the solution, we can kind of force the metal out of the solution and into a precipitant. And this is a handy way to precipitate out metals by adding that common ion to cause the solubility to go down and to cause more precipitation of the solid. In the next video, we'll look at solving the precipitation in a solution where the silver and the chloride are added separately.